Hi everyone, my name is Steve and welcome to my Atari 800 YouTube channel. And for those of you who've been following along, this session is going to continue into teaching you how to use the assembly graphics modes in the assembly What I'm actually using is the Mac 65 cartridge here. You see it plugged into my unit over here, and it allows you to access the assembler editor. You can also use that just using the assembler editor cartridge. Either one should work. Anything that can get you into programming with mnemonics and stuff like that in assembly. Okay, so for those of you who are new to this though, also this is more of advanced level. This is not for somebody who's like into basic programming or anything. I tend to focus more on assembly and things of the higher concepts because I like learning. I like pushing myself to go on how far I can with situations in the computer and stuff like that. So basically I'm going to show you that on the computer here. What I have here set up here in the background, if you see it a little here on my computer there, is I have it set up in graphics mode 0, and it's just basically drawing color lines on the screen. Doesn't seem like they come out very well. This one's actually green, this one's orange, this one's blue, and so forth. I'll kind of keep that in mind when I'm designing it. I'm showing you the program, since you might not be able to see that this is orange and this is actually green. They're so close together. But anyways, one of the other videos I had, I was having trouble getting the drawing to work in one of the modes I had. It set up in graphics 7, and this was in the Atari Mac 65, I think it was game design video. And I found out that I had actually set the coordinates for my X and Y positions, which control the plots on the screen. And because I didn't go back in and I didn't reset them, when I went to draw in a lower mode like graphics 3, such as this one, graphics 4, 5, 6, 7, or whatever, it was actually drawn, but it was drawn way off the screen in memory. Keep in mind this is a graphics mode, so if you're able to move the cursor off the screen, it can keep going and keep going because it's basically moving around in memory. And at that point I realized when I had graphics 7 and I pressed when I first started the program up, I noticed when I moved the joystick, even though I had it set at position 5,5, which is the plot 5,5, it would end up showing it way down on the screen because that's where I basically stored the X1 move and the Y1 move, what are known as, well, they're called labels, but you might want to consider them variables for an easier reference. And what happened is when I went to a lower mode and I tried to move it and I couldn't see where it was because it was drawn way out of the screen. So in BASIC, if you draw a line and you try to draw it off the screen, you'll get an error message. Now in assembly, you won't, because it's all memory structured. There's nothing programmed in to stop how far you're drawn. You actually have to set those coordinates, and maybe we'll go over that today. I like to consider them known as barriers, because basically you're setting a barrier between where you want to position your coordinate drawing system or movement with the joystick or whatever you've decided on. So let's get started on this anyway. Pretty good picture. I just don't know why the colors aren't coming in very good. That might be a little too close. Give me a minute to reposition this to my liking. Okay, that's pretty good, I think. And it's still like way off the screen. I'm going to move this camera over a little bit. Last time I moved it, it shut off on me though. Okay, now I'm going to be real careful this time. It has an on and off switch right on the top of it. It's like a horrible place to put an on and off switch. But anyways, let's see what we got here. I think that looks pretty good. Kind of keeping it centered in the screen, because I notice when my videos come out, it's always either to the left or the right like that, and it's kind of funny. So I can kind of move the camera around a little bit. Starting to get used to it a little bit more. We can get on top of it here. And it slides up and down the monitor here. I can move it around. Let's see how that looks. Yeah, that's pretty good. There we go. I like that. See my guitar there on the side. Okay, so let's go back into the editor. First I'm going to kind of show you the program. I'm going to scroll through it a little bit here. Now, if you want to be able to see a screen scroll as you're going through the basic program, If you type in list, you'll notice it just goes like this and it keeps going on forever. But to stop it, basically all you want to do is you want to press the control key down and the 1 key at the same time simultaneously, and that will freeze the screen as you're going through it, and then you press them again to stop and start the scrolling. So like I said, I'm going to go do this and show you, and keep an eye on my picture. It actually came in pretty good now. Kind of keep it in pages here. And I'll explain this right afterward. Getting closer to the end here. Almost there. Right there. Okay, so you've seen the program. Let me go back over and kind of explain it here for you. Okay. What you're looking at here, these are just known as labels, and this is a place where you can actually store the labels that you may use in your program in memory. These are actually known as hexadecimal addresses. Hexadecimal is an easier way for the programmer to be able to set up the memory statements that they need in a program instead of trying to write out the decimal equivalents. The hexadecimal became a pretty popular system back in the 80s when they designed the assembly cartridge. And if I'm not mistaken, I think it's also a little bit faster than setting up decimal. I prefer a lot of my programs use decimal because it's easier for me to read them, but I probably should get in the habit of using the hexadecimal. Okay, let me do this TV again here. Okay, so let's kind of go down through that here. And for those of you who are new, if you want to convert one of these, like for example, let's just pick one here. This one, ICHID. We're going to convert this address into a decimal equivalent so you can see what it actually looks like. If you looked it up as a memory location, you just type string, that's the $sign, the number that shows there, and it will translate that into to show you this is actually the decimal equivalent for this location. And you just do that for any of them if you want to see what's going on. Okay, I want to focus on this one next. This one right here, x1 move and y1 move, these are actually my own variables, or my own declarations if you want to call it that I've set up to use for the plot and DRAWTO in this program. And these are basically known as, get this direct statement or something, I can't remember what that stands for. But they basically work like the byte statement, and they just allow you to set up basically like initialization for your variables you're going to use in the program. So to start this off, I have this in graphics 3, and it's going to start at position 5, 5. So you can change these to wherever you want the screen, or basically your dot to show up on the screen. Okay, and down here, a little bit ways, we've got actually, I should have probably showed you these. This is a screen memory. This is an address I'm using to store the low and the high bytes for screen memory. If you need a little bit more information, I won't go into a lot of detail in this video, but look up my videos for the, I think it's called Atari Assembly. It's called Atari Basic to Assembly. The first one will kind of explain how the high and the low bytes work for memory. And I have a few other videos that might do that too. But basically, you're setting up a high and a low byte, and you're storing them in what are called zero-page addresses. That's in between memory locations 0 to 255. And then when you're storing them in 0 page, you would store the high and the low byte, so you can find out where in memory you want to be able to set your coordinates. Like for this one, I'm using the screen, so I'll capture like the screen location for 88 and 89 and store them into these addresses to be able to depict where the screen's going to write and stuff like that. And I use that for clearing the screen in this program. And this next one just sets the coordinate location for the text window. In graphics modes, 1 through 13, In 1 through 13, there are actually a little text box window here at the bottom, and this is just showing you where the screen memory is found. I kind of looked that one up myself and calculated it. Okay, this next, we'll call this a function or whatever here, the statement, is actually the start of our program. Now, when you want to be able to use your program for graphics, you would use this, these two commands right here. Use the first statement called LDA number 3, which is load the accumulator with number 3, and that's basically storing a 3 in memory. Think of it as a, if you're looking at it in BASIC and you're used to basic graphics statement, just think of the 3 after the graphics. So that's basically what this whole statement does. It takes 3 and it stores it into a register that's, I can't think of the addresses, 832, what the name of them are, but you can actually look that information up here in the map in the Atari book. Let's do that right now so I can be a little bit more precise on this. Hopefully there's an explanation for this one. 812. This one's going to kind of go into addresses 794 to 834. But if you look at it and hear what it says, it's going to take me a minute to just in the focus. Camera's got to grab it. Okay. I'm going to hold the top now. Okay, so basically what it says here is 794 to 831, handler address table. 38 bytes are reserved for up to 12 inches of 3 bytes per handler. The last 2 bytes being set to 0. On power up, the HATAP's table is copied from ROM. Devices may be booted up such as a disk drive and added their handler information to the table. Trying to see if there's any other information, because the location we're looking for here is 812. Let's see if it says anything down here. 803, screen handler. So see down here, it's basically known as handler, so there's one for the screen handler. Ours is right in between, let's see, keyboard handler. Might be on the next page. I don't see it on this one. Let me look at this a little closer here. Basically, it's a screen address. It's how the computer creates the graphics screen, but this book actually does not explain that I've come across. The DRAWTO may. There's a book called DRAWTO, as I'm reading in here. But I don't think we're going to get a lot of information on these. They're called Iocb addresses, it says right here. These blocks are used the same way as the page 0. The operating system takes the information here, moves it to the ZIOCB for use by the ROM. Well, that sounds complicated. But basically, that's what it does. All things aside here, it creates the graphics mode. This is actually known as, to go back to the program, a jump to subroutine for the graphic, and this is just a label I called in the program called graphic. And let me jump down there real quick so we can stay consistent with this and use the find command to locate where this label is. It's in 2000s. So keep that in mind. Load accumulator with 3 for the graphics mode in JSR graphic, and as I go down to this location here, you'll see that this is actually the area that creates the graphics screen. I won't go into a lot of detail how to explain this since I can't really explain it. It's not actually my own work. But over here you kind of see a little explanation. It stores it on the stack. That's what a push does. It always takes the number that you're using in memory, stores it on the stack when it wants to use it. And it basically, this works as it says something about a close command for screen close command. So it's setting up all the things that you can probably use. And I think this goes from the open statement to the graphic statement. It's pretty large to the degree that it actually covers. That's why the locations in this book that I showed you earlier go from 794 to 831. It's called this handler address table. It's a table where it stores all this information. Right here you see the open command is stored at, and they use number 3 to access that in ICCOB. And these registers here are those same labels I showed you at the very beginning of the program. If you go back at the beginning of the video, maybe rewind back there a little bit, you can kind of convert them if you have an assembly yourself and find out what location they're pointing to. That's basically what this is doing. It's just setting up the high and the low byte in memory to be able to access where this call is being taken from. So I never really tried to study it, but that's basically what it does. Down here it's masking a value so it can get probably the correct This is a get high 4 bits, flip high bit. So it's basically what it's doing is just creating that graphic statement to go into no huge explanation. Now let's get back to work here. Maybe I'll look it up in another video and explain that. Never really took the time to learn it. Excuse me. So the next command here, you see it says LDA number 1, says load the accumulator with number 1, store it in a variable we call DRWCOL. This is abbreviation for draw color. So this is going to allow me to change the color. When I press the fire button in the program, it'll change the color. And I just set it at 1 because that's the first color. The next declaration I set up for myself here is going to be my X and Y coordinates, which I showed you earlier in the program, was set up in those DS statements. And basically this is, if you see my other video, I had the, I think it was the Atari Mac 65 programming or something like that. I ran into the very end of the video and I could not get those things to move, and this is how I found out why. This is exactly where it's all happening at. It controls on the screen where those things are drawing at. So when you're setting up a new program, you always want to initialize them so you can keep them on the screen. Okay, so down here we've got Jsr Show Message. I had to look to see what this one is for. Oh, I think I drew a message down here in the window or something to keep track of. I was going to have it, when you draw the line, it was going to draw and keep track of the X and Y coordinates, but I haven't programmed that into the screen coordinates yet. I use the binary coded format to be able to, binary coded decimal system, to be able to convert that into, so that we can see it as an actual number. Okay, so the next statement here, this is kind of the body of our program, the heart of the program. This is just setting up another label, draw, and this is going to be like our main loop here, basically. And this is load the accumulator with DRWCOL. So it's basically taking the number 1 we stored into it and stored it into the color statement. Now, I can go back to the down here to the bottom if you want, or you could go back and rewind the video if you want to see that. But basically, all this is doing is just plotting a color. If you look at, if you're familiar with Atari Basic, what we've already done here to this point in the program is we've typed in graphics 3, and then we typed in color 1. That's basically what we've done at this point. So it's just drawing the color. This next statement begins our plot and keeps track of where our dot is on the screen. So if you don't use this the plot statement with the X and the Y coordinates and all that, when you're drawing and going back to a loop, you're not going to be able to see your dot until you start moving it. So you basically tell the computer where is it showing up at. So it kind of keeps track of it all the time. So that's what this does, is it keeps the X register, stores that into the declaration we set up for X1 move, which was 5 up there. And same thing with the load the Y register with Y1 move with the same thing, number 5. So we're basically storing those indirectly. Okay, so the next part here, this will take you a little step up in some of the things you haven't learned yet, but let's look up this location right now before I go into it. I'll show you what it does. Okay, hold that call. Okay, so what we got here, wait for that phone to stop ringing for a minute. Okay, so right here it says 53279 console, CONSOL, and then basically, if you can read there, it says use to see if one of the 3 yellow console buttons has been pressed, not the reset button. To clear the register, poke this with 8 whatever. Basically, if you look down here below it, keep this in clear perspective there, you see where it says option there, select start, and you see those values over next to it. The option points to the 3, the select statement points to, is pointing to the 4, and the 1, oh, those are probably the bits, the assembly bits. And what it's doing is, if you go down here, I think they have an example of how to access it. What we're doing is we're going to be controlling those console keys on your Atari keyboard, the start, the select, the option. Those are the, let's see, select, start, option, and there's the help key. I guess those are the only ones on there. Well, that's basically what this is doing. is it's taking this location indirectly and saying, okay, we're looking at location 53279, which holds the console information stored in the Atari computer. And then this next register says CMP, which stands for compare number 6 to see what's in this location. The 6 represents the start key, so it goes into this next branch which says branch is equal. We're going to go to a label that we've actually called start key. And that's just what it's going to do. When you press the start key here, what I have it doing is I have it clearing the screen when you press the start key. Okay, so the next line here is very similar to this one. It's just another location, and I've showed this in many videos. To save some time here, what this does is says load the accumulator with 632 memory location, which controls the joystick. This next location, next statement here says compare number 7 to see, did you press it toward the left? If you did, we're going to go to the label that's called go left. And the same thing here for the same ones. These are just basically comparing them. So when you want to compare a series of statements and you haven't shifted or changed anything in memory, you can just use these branch equals one after the other like this. So this one checks the left press of the joystick. This one presses the right. This one checks for the up. And this one checks for the down. Okay, the next one here is the fire button. This is the memory location where the fire button is stored. Anytime you press the button on the joystick, it's going to represent a 0 in memory, or a bit 0 basically. And it's going to go to a label here we call it change call, which is change the color. This next statement is pretty important. Jump draw. If you don't jump in a program when you're trying to set up a loop, it'll just keep going right down through the program and it'll hit the next statement, which is not what we want. Because we don't want it to say, if you didn't do anything, go to the start key. We didn't even press the start key yet. So basically you want to make it go back to the program, which jumps it back up again. And this is the start key as I showed you earlier. This is the location that stores the clear. It's called jump to the subroutine called clear SCR. And again, we're jumping back to the program. And everything here kind of follows the same consistency. It's just going to go to, and see, once you press the left, what we're going to do here is we're going to start moving the coordinates of that little dot on the screen toward the left. What this one says is increment x1 move. Now keep in mind earlier x1 started at 5. So if you increment x1 move one time, it's obviously going to be at 6, 7, 8, 9, and so on. And this one is called Jsr plot me. It's a label that's going to allow this dot to show up on the screen and you can see it moving. And this one returns to the loop. This one does the same thing to right, so it's very similar to this, except you're going backward. It's called decrement x1 move. So this time we're going backwards. So if it's at 5 and we move it backwards, it's going to be 4, 3, 2, and so on. This one here is the up position. So we're keeping track of the y coordinate. And think of this as the screen as a series of pixels, which if you look closely at any TV monitor, especially like an LCD, you can see that there are dots actually inside the cells, or what you want to call inside the TV there. And what this does is it sets up a plot and a coordinate anywhere within this spectrum. So in graphics mode 3, the dots range from 0 to 39, and they go from 0, I think it's to 19. I know if I got a 19, I usually get error messages. And you can plot anywhere within those coordinates. And the next thing here is, let's go down here. It's the reverse. It's the up. So if you go up, you're incrementing y1 moves. So just think of this as you've got the little dot on the screen. It's at x comma y. If you want to move up, it's going up like this. So it's basically decrementing. If you want to go down, it's decrementing. It's incrementing the y1 move. If you want it to go to the right here, it's incrementing. If you want it to go to the left, it's incrementing this one on the first one, the x1 move. Because this next location here is, this is the one I mentioned earlier. I think when we pressed the option key, was it? It's going to change the color, no, the fire button. It's going to change the color of the dot on the screen, and this is just what I use another label to keep, or variable if you will, to keep track of what that color is going to be. So it's incrementing DRWCOL, which started at 1. So if you increment it, it's going to go 2, 3, 4, and so on. Now pay attention to this next part, because what it says here is we're going to use another comparison, or an if condition if you will, in BASIC. and it's going to say, okay, so this little label that you've set up, you've incremented it, and it's going across in memory. Keep in mind, anytime you increment a value in memory, it will go from 0 to 255, and it'll flip back to 0. So we don't want it to go all the way to 255. The standard colors in Graphics 3 are 3 colors. Well, 4 if you count the 0, which is actually the background. But since we wouldn't be able to see the dot in this program, we only use, I did set the 4 in this, so I guess I do have it, so if you want to move the dot around, you can move it around. So it's keeping track of, see, did you go through 4 of these increments in memory? So once you hit 4 in DRWCOL, here's the way to look at it in BASIC. If DRWCOL is equal to 4, actually is greater or equal to 4, then we're going to fall into this next statement, which stands for a branch carry set, and it's going to allow it to trap it so that that barrier doesn't go over 4, and it's going to reset the color. This is what this is doing, reset col. It is put down here. If you look here, it loads the accumulator with 1 and puts back into that location DRWCOL, which is being incremented right here, 1. So it's basically keeping track of it. So if it starts at 1, you increment it and it becomes a 4. Instead of going all the way up to 255, it's going to go back to 1. And this is draws and keeps it in the loop. I've showed this one in several videos. I won't go into a lot of detail with it, but it's a delay and it slows down the program. If you don't slow it down, if you watch my last one, Atari Max 65 programming video, I demonstrate what happens if you don't slow down and set up a delay in assembly. I mean, it's pretty fast. Everything will go at lightning speeds. Okay, so the next thing here is going to keep track of when this is actually what's storing your location for X1 and Y1, and this is being used by all the joystick coordinates I set up from up, down, and left and right, and it's just plotting them in those coordinates. This next one might go a little bit over your head. This is an easier way to clear your screen if you don't want to just have to use Graphics 3 or Graphics 4 over and over again to clear the screen, or use something like print CHR stream. I think it's 125, and you can also use print 2 colons in BASIC, and you can use the up arrow to clear a screen too, but you would use the number 6 when you're clearing a graphics screen. And that's what this is doing, except this one is doing it in memory. It's keeping track of the high and the low bytes, and we've stored our location here in X1, Y1 move, so we're setting it up at 5 so we can reposition our X1 and the Y1. So if our dot is moving and we got it way down here in Graphics 3 or something, we use this X1, load accumulator number 5, store it in the X1 move and Y1 move. It's going to put the dot back up here at 5,5 again. And these next lines are keeping track of the screen low byte of screen memory 88 location and screen memory 89 location, and keeping track of their low and their high bytes so we can set up the screen player. And if BASIC, if you want to look at it, use this actual, I'll write it down here on the screen so you can see it. You would just type something like SC equals peak 88 plus peak 89 times 256. And then that will store the low byte and the high byte for your memory coordinates. And that's what this is doing, is it goes into and it stores the memory location. I have this X register up to 30, so since you're going through the low and the high byte, when you're incrementing through a memory location, it can only go from 0 to 255, so they flip back to 0. I think it's called the 0 flag, flips back to 0, and then it flips, I said 0, it goes to 1, and you would set an add with carry to get the next memory location, which is what this is doing. As the X register is going here and becomes 1, it flips it back to shift up the next pointing memory. So if you look at this in memory and you've got memory location going from 40000, that's a screen coordinate, the only one I can think of for graphics 0, and you get the 400255, if I said that correctly. Let me show you on the screen here. So if you've got memory location, screen starts at 4000, and then you increment that location in memory. Let's just say, what did I call it? I called it SCRN. As it's incrementing, it's going to say here, as in BASIC, if SCRN is greater than 255, then we're going to flip this one back to 1, and this is going to pass it into the next low and high byte. I'm probably not doing a good explanation of this, but basically what it's doing is you're looking at it this way: 0, 0, 255. So once this location's hitting 255, it's going to flip back the low bit to 0. I got it now. And the high byte's going to add 1 to it. So it's going to increment this location by 1. And if we increment this location by 1, it'll go to this one, obviously. And that's how the high and the low byte work, is it's going to reset this X register and then kind of carry off where it left off at to go back and rewrite the screen again. Let me put the screen back on here again. Hopefully that one didn't go too much over your head. If you follow assembly, you can probably understand what I'm talking about. Just takes a little bit of time to grasp it. So once you've got that, you're going to store it into what's called the zero-page addressing for the location we set up in memory, which is SCRN. It's going to keep track of those high and those low bytes in memory. And this is just like, if you see my other videos where I store it in like the 203 and 205, this is what this is. Think of this like as a memory location, 203, and it's keeping track of those high and those low bytes where your screen is, and it's flipping it up. This is the value right here. It's going to branch back to. So what this is doing is incrementing from the Y location here, which we set at 0. If you increment the Y location, it's going to be a comma 1, which flips that back up. So then the next location can go from 255, 256, 257, so 40, 256, 40, 257, and so on. As what it's doing is basically in screen memory, and it's keeping track of where it is going to be on the screen. So this next memory location is needed for the high byte. So we can flip it over. This one here is called decrement the X register, which keeps track of it once it's going back to 0, and if the bit has flipped up to 1 for the high byte, it's going to decrement the next location in memory to keep track of the screen drawing. And what this does here, I forgot to explain this. A load accumulator 0 is going to be used for the 0 character in memory. If you change this to any value like 1, 2, or 3, you would actually do a fill screen with whatever value you put in there. So if you put 0 in, it's just going to go through memory and just put zeros in here and wipe out the whole screen. Yeah, I probably won't go into the... Oh, I could explain this one. This one's very similar to what we did above. This keeps track of the 88 screen high and the low and the high byte here for the screen memory. And this is setting it up for my next drawing, which I'm drawing a message on the screen. This right here is stored in what's called a byte. I think it's called a direct reference or something. A directive? That's it. Let's go back and we'll search for that one. PRMSG. I'm going to set it down here a little bit. Find out where it's stored at right there. Okay, so what this is doing is it's taking what's called an S-byte directive, which is used by the MAX65 assembler cartridge, so that you can implement actually characters inside them instead of just using stuff like numbers in general. So this one's just going to just draw the color down here in the text window. That's what this is doing. It's plotting in the text window here. If you see what's a stored text window, it's going to write the word color. So what this is doing is it's going through that location on its Y addressing. If you look at it, it loads the accumulator with Y. So this first value is going to be 0. And as we go PRMSG to this location, and we're hitting 0, we're looking at the C right now. So when you go through the loop here, it's going to store this in the screen. This is for the high and the low byte. If you increment Y, suddenly it's going to become a 1. It's just going to go to the next value. Pick up the O, 2, 3, 4, 5. That's how it draws what you put down there in the label. And this is keeping track of where to store it out on the screen. And we kind of went over this earlier. Just look back at the earlier example. You need to rewind on that. And it's working the same thing. It's just flipping the bits to pick up the next location in memory. Okay, I won't go into a lot of explanation about this. I kind of went over these earlier, but this one stores the color. This is changes our color in memory. It's just one location that keeps track of it. Actually, let me look up that one right now. I'm curious. I'll convert that, see what location that is. So it's 205. Let's flip back to our mapping Atari book here, so those who are new to this can understand what that location's doing here. No, actually, I just realized it's nothing in memory. It's just they're using it to store a color and an address in memory that can be used that's unused by BASIC right there. So 203 is unused by either BASIC or Assembler cartridges. So that's what they're doing, is they're keeping track of the color in that location. Let me go back here. And that one's pretty simple for the color, so they keep track of it and they draw it. What they do is later, this, we might find it down here, but this label is being used down in one of these programs to get the color. I'm pretty sure that that's how this works. I might be wrong, but we went over the graphics one earlier. Position, just use like the position statement. I think this is location 87 and 87, 89 or something. Trying to do these directly out of memory. It's been a while since I've played with these. I think it's 87. Says display mode, current screen mode. I think that's it right there. Well, let's show you in the book. Here's 87. Here at the bottom. Display mode, current screen mode. So what it's doing is it's just controlling, and I might be wrong in it, but this is keeping track of the position, which I don't use this one, but you can position a dot like in graphic 0 and stuff like that. I just prefer the screen, high and low byte addressing. This one is a plot. It works with very similar to what we did earlier with, I just noticed this location is being used by that. It works very similar to the graphic statement. It's just using these same handlers from the handler table that I showed you earlier. DRAWTO does the same thing too. It just uses a little bit more, goes into a little bit more detail here about how the DRAWTO command's working here. Command, this is called the command byte. References this in the X register, whatever this hexadecimal address is. These are called auxiliary, and this is how it basically sets up that statement for the DRAWTO. And then there's the locate. Locate is just like if you watch my first video called Atari Simple Game Design, I believe it is. This one uses the locate X, Y, C as an example for locating where that dot may be, whether it's running into stuff for collisions and stuff like that. This one out here, I don't use this in reference to this program, but it's a vertical blank interrupt. I was going to just change the color screens, and this one I was probably using this from game design, like a game demo or something I was creating. So I won't explain a lot about that one since it's not being used in this one. This is taking from a game extract I had, broken down to use a drawing program. I don't think any of these are being used. This one is being used by I think this is the graphics mode. This keeps track of the S, and this is being used in an open statement if I'm not mistaken. These are just being used by the game designs, and this is just for character sets. So these are not being used in this program. I was using them in there, but I left them in there from before. So let's go ahead and start doing some more work here now. I'm sure you probably heard me rattle on enough. So we're going to start doing is I'm going to set up some drawing locations here and maybe have keys, draw pictures and stuff like that. I think that might be a good way to start this. We got the start key here. So I'm going to set up another key here. I think 3 is the option key. We're going to set it up. If you press the option key, we want to draw a picture on the screen here. We're going to use this location for draw picture to start drawing and changing pictures. I'm going to show you how to really use the plot and the DRAWTOs in assembly. They work very similar to the Atari Basic. So if you pay attention and watch carefully, you'll find out just how easy that transition is. Let me remember this. Find a safe place to put them here. I'll stick them right down here so we don't jump over the boundaries. Simply. for those who want to know what I was just talking about, jump over the boundaries. If you set a register here, as an example, BCS reset color, and you have this one jumping down in memory, think of this, and if you look at my example for, let's see, which one is it? Atari Basic to Assembly, I explain this. As the data statements are going through memory, you're keeping track of, or they count where they're counting at. So if a branch is going through memory, it's counting that location in memory. So if you're going forward in memory, it's going to count from 0 going forward. So what this is doing, since this is made up of 2 here, it's going 0, 1, and this one's made up of 3, 2, 3, 4, 5. So this is going to jump forward 5 segments of memory, and it's going to start using this label, or this function, you will, that we've set up in the program. Now the reason why I'm explaining this, because if you jump too far forward in assembly, you'll get error messages, because you can't jump over, I think it's called a, I can't think of the error message, but it won't allow you to jump over certain bounds. It'll give you an error message, and it'll say it doesn't understand it. Maybe I could do that in the program to kind of show people who are new to that. I'll just save this one and comment this one out for now. We'll make this draw way down on the screen here somewhere. So draw picture. I'm going to put it way down here. So we got it right up here. So we're going to go past what's called the 128 byte range. So we can get that error message. I think down here anywhere would be fine. I'll put it way down here. 21, draw picture. We won't do anything with it now. We'll just return from it. I should be able to get the error message though. There it is. Okay, so what it's called is called branch range. It means you can't go past 128 bytes. If you do, it's going too far in memory to be able to locate it. I can't explain that from a logical perspective how to work, but just know that you can't go over the 128 bound range. That's a pretty common error in assembly, especially when you start setting up real huge programs like games and start moving your functions around a lot. Okay, so that's at 840. We'll remove that one. We'll go back to our other one here. 1000. Down here somewhere. Right there. We're going to start working off this one now. Okay. So what we're going to do, we're going to draw, what we're going to do, I need to type here. What we're going to do is we're just going to draw a line going all the way around the screen here. Maybe later we could just make it draw like into the center of the screen or something like that. I just want to just demonstrate how the drawing kind of works in assembly. So it's going to be a little bit complicated, but I'll explain it here with basic statements over to the side. This one is just used. This load accumulator 0 is always used when you're using this DRAWTO JSR and plot. So just use the load accumulator 0 first. And the next one's going to be our Y coordinate. Since we're starting up since we're going to be starting in the upper left-hand corner, we're going to set it at plot 0, 0. So this is the Y coordinate for the 0. So I could probably set this up like this. It might make a little bit more sense. Actually, I should do it. I almost forgot to turn on the color here. Let me just kind of push these down a little bit. Oops, I just like to use all that. I think I just did. See what happened here. Remember that. Alright, let's see. X register 0. Y register 0. Okay. So let's go ahead and run the program right now. And when this works correctly, you should see a dot in the upper left-hand corner here, and it should be orange. Oops. What did I do wrong here? I think I left the other one here or something. Oh, How about the other label now? What that error message was saying is there's a duplicate label and it doesn't understand which one to go to, so we're going to remove the earlier one. Okay, I think this one is drawn in if I can find it. So this is the one in the program already. Oh, we have this set up so if you press the console key, it's going to show a dot in the corner. It's not doing anything yet because we haven't told the computer where that dot should be plotted yet. So if we press the console key over here, it should appear. I think it's the option key. The option or a select? There's something going on. Let me have a look here. Let's do some investigation here. Start key. Oh, got to set it up here. Oops, I think I just forgot to. I'll explain what happened here, why it didn't run the program that time. Where's my label at? Down here, right? Okay, so what just happened here earlier is it went, when we pressed the option key, earlier it tried to go to the other label, and since it had a return subroutine, it would have just jumped out of the program, but because we had two labels, it was giving an error message. So I removed that one, and the second time here, if you go back up here in the program, let me kind of go back up here. Precise on this. I tend to be very thorough, so people who can really follow are kind of beginners and stuff like that. So earlier here, when we set up and checked for the, I believe it's the option key here, it didn't have this branch here, so it just moved into the next statement. So it didn't know where to go when we pressed the option key. It just basically skipped this compare and went down to the next one to check the next compare instead. So 1400. About where was that? Okay, down here. Okay, so what happened here earlier is when I went to run the program, just now it went to, when you press the option key or select, it went to our label here and it started drawing our color and got ready to set up our plot, but look down here. What's going on down here? Look up here. It's not going back to the program. So it just basically went into the delete statement and exited out. So we couldn't see anything going on at that point. So that's why it just breaks out of the program. If you don't have a return subroutine set up and you're setting a branch to go to that location, then the computer doesn't, well, not a Jsr, if you're setting and you don't tell it where to go, it's just going to follow the next statement in line. So at that point it didn't know what to do and it just basically would have crashed your program if you did it in BASIC. You want to use a return, and now return jump back to the program. You should get it this time. Didn't see anything that was flawed. There it is. Okay, so when I press the key here, it appears in the upper left-hand corner. So now we're going to start using that to draw across the screen. So I'm going to teach you the DRAWTO statement next. Where are you at? There it is. It's at 1200. I'm just going to draw it out first, write it out here, and I'll explain it. Okay, so what I did here is we took where that plot was at, which is a 0, 0, and now this next register says load the X register with 39. So as you look at it in BASIC, you got plot 0, 0, and the next thing we're going to be doing is we're going to be drawing over on that X line here, or horizontal line, at location 39, so it's basically drawing it in memory at location 39. And the next statement here for load the Y register with 0 is just keeping the Y at 0, because remember, Y goes from 0 to 19, X goes from 0 to 39. So it's basically taking 0, 0, drawing it over 39, and keeping it on that same Y register for that first vertical axis, if you would, at 0. So it should draw the line directly across the screen if we've done this correctly. So there you go. So it's just drawing the line real fast across the screen here. So we're going to finish it up and make it draw the circle now. We're kind of running out of time here. Let me go back and translate, as I promised, for the people who want to know the basic part. Let's go up here. Well, this whole line here, of course, when this one is going to be, move this back a little bit, color 1, and these two lines here, the plot statement, are going to be plot 0, 0. Down here, I'm going to go DRAWTO, 39, 0. So as I'm writing them out, I'm just going to put these comments out to show you exactly what these lines are doing and see if you guys can kind of follow it that way for time's sake. Got the line moving down here. That. Remember that? Got one more to do. Finish the square. Oops, that's in the wrong spot. Check it to make sure. You got a 0, 0, DRAWTO over 39, 0, and then now we're at location, we're at Y register, we're at X register 39, so we're going to draw it down to 19. That's what this one's doing, DRAWTO 39, 19. Now X is at 39 and Y is at 19, so we want to draw back over to 0 at the X register, because we're keeping track of where X is, and Y is staying at 19, so we're drawing it over, and then we're just returning to the top at 0, 0. So it should work. I think it looks good. Find out. There we go. So now you see it's drawn a complete square around the screen. Let's take this a step up. Hope I don't lose you guys on this one, but I'm gonna do some fun stuff with this. How much time we got left? We got 5 minutes. See if I can do this in 5 minutes. Let's see. What I'm gonna try to do is get it to draw lines until it hits the center. Might be a little bit more complicated than it looks, so we're going to have to keep track on X and the Y registers. I'm going to have to basically create these up here somewhere. You know what, I think I'll keep this simple. I'm not going to go that route because it would just take a little bit more time. It might be a little bit more advanced for people who are just kind of learning. It wouldn't be fair to people who are just starting to learn this stuff. So we're going to basically just kind of draw a picture or something here. Maybe draw a smiley face. I think that'd be kind of good, kind of cool. Get my calculator out here for a minute. Trying to figure out where to draw these dots at. So if we move into location over, you might want to try drawing it at, maybe try 6. I might have to be calling out sometime at 19 divided by 2. 9, maybe 7 would work. It's going to be something like see where that dot's going to position. What I'm going to do is try to draw a smiley face and draw eyes and a smiley face on the screen. We have time here. See where it positions it at. There's a positioned it over here. We still have our other dot from the original program, so let me remove that so it doesn't interfere with this one. Just for now. Going to be about right there. Is that correct? Let's see. So try to get that dot maybe over here somewhere. Move it a little bit. So 12. Let's try that. That's not too bad, I think. Okay, we'll position the other eye. We'll change the color too, so it looks a little bit better. Okay. I didn't draw it any flat. Let's see where that's going to appear at. The second eye. That's too close. We're gonna need to move it out a little bit more. I forgot to change the color. Let's change the color to it. Let's try that. That's not too bad. Now we're going to draw the smiley face, so we need to figure out where it's going to position that. Let's see. How about that accumulator? 12,6. Maybe set this one at 14. And Y 15. Let's see where that starts at. Oh, let's apply this off the screen. Where'd it go? Oh, I see what I did. That's a little too far down. We want to kind of move it maybe up here somewhere. So I'm going to move it at one location beyond this and move this up maybe about 3. That should do it. We've already reached an hour in this video. 12 or something like that. I'm going to change the color of it too. That's a good spot to start it though. We'll make them out. So they're the only color we have here. Where'd my color go? Now we set the plot for the mouth here, which is going to be at 3,12. I'm just putting in some fillers here so people can see what these are doing. This is the right eye. He's not going to have a nose, it's going to be a simple smiley face. For time consistency here. Now we're going to use a DRAWTO statement. So we're at 14,12, so we want to move that line down. So the X register is going to be increasing and the Y is going to be increasing at the same time. So let's go ahead and figure out maybe, I'm going to try 17. And we'll move Y at the same rate. Or maybe not as far. We'll kind of shift Y down. Let's see, so this one's going down 3. We'll set Y down 2. That might look okay. Got to set this one here. Double check those, make sure those look good. 12,6, 25,6. Okay, so let's go ahead and remember this. See what that looks like. Not too bad. Okay, so now we're going to just move the line over a little bit and move it back up for a smiley face. Try to do that all in one standing here. You can see how long it takes and a lot of work it takes to get these plots and DRAWTO in assembly. I don't recommend using them for everything. You take a lot of time. You use them. So let's move this over maybe 20. We'll test this one. Y. Alright, let's see. He's gonna look pretty funny, but we'll see how it comes out. And we'll return X and Y back to the other side. Complete the mouth. Let's see, it started at 14,12. So we want to move X register. Let's see, 17, 20, how's this going to look? It have to be 3 again. And Y register over 2, was it? And Y has to go to 14. 23 complicated. Let's see what that one looks like. Maybe it doesn't look too bad. Oops, what did I do wrong here? Yeah, I forgot to change the location. Alright. Let's see, X register. Oh, I forgot to load the accumulator. You don't use that LDA 0, can't figure out what to do with it, it won't draw it. And something else is going on. It's drawing the line over. I notice it's not changing the Y location. Let's see, I'm trying to rush this through because I've already hit an hour. 20. Oh, I left Y at 14. No wonder I was looking at the wrong statement, so I wanted 12. Do it. It's not a perfect smiley face. Maybe it is. And that's basically what I wanted to show you in this video. Moving up, going to see it. We're already kind of out of time on this one, but you can see using the plot and DRAWTO the kind of cool things you can do in assembly and stuff. So if you're interested, you can definitely go ahead and subscribe to this channel. I don't know why my camera's losing focus here. And like I said, this one is for people who wanted to learn a little bit more about graphics and stuff like that. I'll move my camera around here a little bit. But I have a lot of good videos on here for the beginners and for the advanced alike. I don't know why my camera has just gone completely blurry.